So hello again. Tonight we're going to talk about weather modification. We'll get into a lot of minutia and a lot of probably information that you haven't heard dating back many decades. Ought to be interesting. People may have heard of weather modification on a particular episode of Star Trek: The Next Generation, something called the weather modification net that should have dissipated a tornado but didn't. Q at work, actually, the Q continuum at work. But in this particular instance, yes, what I'm saying is weather modification is limited area, short-term duration, modification of active weather conditions. It's a real thing. We'll get into the actual evidence of it. This is active weather, as in short-term. It's not climate change, which is long-term. It's limited area, which means it might be, a city, a county, a portion of a state, maybe not, in a bigger state, not statewide, maybe in, I don't know, Rhode Island, it might be statewide, but Texas, it certainly wouldn't be statewide. Not country regional, so it's not going to affect all the US, not national, and certainly not global. And it's going to be short term. It might affect the weather for minutes to hours to a meaningful portion of a day, not for a number of days, and certainly not permanently altering the weather in an area. Once the application of the modification ceases, nature will retake its course, things will collapse back in, and you'll have normal ambient weather in the area. Now, the level of modification is more subtle. It's not dramatic. It's not catastrophic. It's not, the weather modification that will create biblical floods like some sci-fi movie, and it's not Ming the Merciless Emperor's hot hail. We're just making some subtle changes. Now, what kind of changes are they doing? They're actually changing to a small degree. Here's a pun. Temperature, atmospheric pressure by millibars. Winds, not by hurricane force to non-hurricane force, or creating a tornado out of nothing, and precipitation, which could be rain, snow, sleet, or ice. So we're talking about what we can do. Now, why would you ever want to do this? Defensive. It's to protect people against bad weather, protect property, infrastructure, because there's windstorms that aren't even hurricanes that can damage property and create flooding. There's storm surges. There's actually flooding from heavy rains, monsoons. Tornadoes kind of come out of nowhere, but they don't. They can actually be, very short-term predicted. And then there's hurricanes, which we can see from a long distance coming away, track them. Now, why would we want to do this? Because there's productive gain for the benefit of people. We don't want to be harming people. We might want to green things up. We might want to take an area that used to be known as farmland that, because of whatever change, they're now a lot drier. We could bring some rain back to that area and, restore the parched lands back to agricultural benefit. We could warm things up. We could find a spot that had a lot of water that, we don't have to evaporate the water, but if we just warm it up a few degrees, nature will take its course and the water will come off. We might want to, an area that has seen a lot of ice and snow and sleet, pump it up. If it's already, just a few degrees below freezing, the difference of, salt being put down on roads is enough to change the freezing temperature of water by, I think it's only 6 or 8 degrees. So that's enough to melt the ice off of roadways. Well, if you were close to freezing and you changed it by just 3 degrees over a certain area, you could have the same effect. And what if we just dissipated clouds over an area to increase sunlight, more photosynthesis, more agricultural yield? So there's reasons for doing it. That's very simple ones. Now, What are the incentives for avoiding it? We obviously want to minimize loss of life, reduce injury, minimize communal grief, PTSD. So there are, other than just, direct financial gains for avoiding these weather incidents. Maybe we don't fully eliminate them. We just mitigate them a little bit, make them not quite so bad. So we might take an area that's under drought and make it a little less droughty, a little less drought. An area that's been flooded or seen a lot of precipitation, we might back it off a little bit. If we can avoid adverse weather effects on an area, there might be other sorts of things. But if we can knock it down a notch, if we can take it from, a Cat 5 tornado to a Cat 3 tornado, an F5 tornado to an F3 tornado, that's a big difference. A hurricane, we can take it from a Cat 5 to a Cat 3. That's a big difference. A windstorm that doesn't last as long or is less intense, or the winds are not as high, that's a big difference. So don't have to cure it perfectly, but just change it a bit. Now, what would be the incentive for a corporation to want to do this? First thing that comes to mind is insurance companies. They insure lots of stuff. And if they have an untoward weather event, they're going to have to be paying out big time. And it's not just, rebuilding your house or putting your roof back on. It's all the indirect stuff. The labor, not just the labor for the repair, but architectural labor, contractors, architects working on things, general contractors. That's just labor intensive. What about communities? There's services they have to pay for, like permits, building permits. Getting your roof redone requires a permit. What about utilities? If your house is sufficiently damaged or your business is damaged that you had to go off grid, you have to pay the utility to reestablish the grid, and somebody has to come out to do it. What about medical insurance? Emergency services, be it ground level, ambulance or helicopter air rescue. You're going to take somebody to the emergency room. That costs a lot of money. And if they're injured, intensive care unit for, a few days to a week, and then a longer hospital stay for your recovery. And then once you get out, if you've got physical damage, you may have to have, rehabilitation therapy, or if it's critical, you may have to go into hospice and you're only going to last 30 days or so. Medications, physical therapy, psychological recovery for PTSD. So all of that is the cost of the weather event. And then what about life insurance claims? Funeral costs, burial costs. All those are things the insurance company is going to have to pay out. So if you could dial down the weather just a little bit, how much profitability would the insurance company see by reducing their expense outlay? So a hurricane devastates Florida, and instead of it costing $15 billion, it costs $5 billion. That's a $10 billion savings for the insurance company. If it only cost them a couple of $100 million to develop some form of weather modification, it would be worth their while to do it. So if a private corporation ever came up with weather modification technology, would a company ever want to pay for it? Well, if the price was right, yes. But if the price was, held out as do it or else, that's what the insurance companies do themselves. They're not going to pay for it. So once the technology for weather modification, that cat, as the saying goes, is out of the bag, and all kinds of companies, small, large, meaningful, safe, or haphazard, are doing it, yeah, chaos could ensue. So what about at a local level? Community savings. We're not talking about your home or your business. We're talking about your local government. Search and rescue. When you flatten a city, like some of these F5 tornadoes have done, you have to go find people that might still be alive buried under the rubble. And you do that for, a week, and then you start, just search because there's no rescue attempt anymore. That takes a lot to get rid of the debris, to, fire rescue, emergency services, law enforcement to make sure that, nobody goes in and does bad things to the courthouse while it's being repaired. And you still have to run your government. So you've got to find and pay for alternative facilities until your primary facilities back in operation. You may have to bring in external companies and pay for them because your local government may not have all the equipment for demolition and debris removal. It costs a lot of money. And then once you've cleared it up, cleaned it up, now you got to rebuild it. If you've had a courthouse that's been around since the 1940s and it gets leveled by an F5, that could be hundreds of millions of dollars that taxpayers have to pay to rebuild their government offices. Not to mention public works. If you get a local subway system flooded out, or your buses get destroyed, or trains get derailed, or your airport gets shut down, or your seaport gets shut down, it costs money to bring those back into operation. If your water service goes bad because your water purification plant goes offline for a few days and everybody's got to boil their water, or it costs money to give everyone free drinking water, even if it's just inexpensive filtered water in mass, that costs money. And you've got to get all kinds of services back online, your water purification plant, your sewer processing plant. And what about your green areas, your parks and recreational facilities? If you remember when the hurricane came through Florida and it took out a lot of trees, it was nearly $8 million in landscaping recovery for the Broward Park system to get the major parks back in operation. So a little bit of weather improvement goes a long way. So here's the reasons for not doing it. Sad to say, here's the human story: gain. Well, if nothing was going to get destroyed, you wouldn't stock up. You wouldn't be a prepper. You wouldn't go buy a ton of paper products. Everybody needs toilet paper, and then the stars have a run on toilet paper, and then the hurricane actually never hits. Well, you paid for the toilet paper. You're not going to be buying it anytime soon. So that's a ride through. But, the companies that make toilet paper sold far more toilet paper than they ever would have in the same time period. Filling stations. You top off your vehicles, you fill up your generator cans, your chainsaws, your mowers. That's extra stuff that they wouldn't make the sale of. What about home supply? People buying tools and power cords and plywood, or plates to cover your windows, and then got to have the generator to keep the refrigerator running, because if you have one of those big giant double door refrigerators and you can't keep it running, it might be $500 worth of stuff you have to replace. And so you're going to go buy a $500 generator to just run the refrigerator. Post-disaster recovery and resupply. So you ran out of perishables because you were without power for 3 days. So now you have power again. You go to the store and you buy all new stuff. Communities have to do that too. Filling stations. They may have run out of gas at the local stations and they have to pay for, we can't get the fuel from Port Everglades because it's shut down. So we have to get fuel in the Broward County area from West Palm Beach or up from Miami. That costs extra. And then once, post-disaster recovery, home supply, you need new appliances or tools or temporary patching, blue tarp to get your roof back, or permanent repair. And then all the people that are considered labor associated with that stuff. And then permits and inspections. But that's not the real pain from that, gain. What about people that get injured, people that don't make it through the other side, things that need to be secured and protected? You get runs on hospitals because people just can't get the treatment they need. So that cost extra, and those are usually revenue-based things. So, medical care and pharmacy and all the related services, and then the if you didn't make it services, that's money that wouldn't have occurred otherwise. That's gain. I won't say ill-gotten gain because there's services that people expect and need, but I will say that if you could diminish the weather effect, that's gain that would not occur, and somebody might like that gain. So is there anybody that wins by the gain alone? If there's no incentive, then why do it? But if there is incentive, then why wouldn't you do it? And that's when you look at insurance companies. Sure, insurance companies have the billions to make the technology exist, but would they do it? They would certainly benefit from it, but they won't spend the money to do it. They would rather have your tax dollars, have the government create the technology, prove it out, get it going, because insurance companies are in the liability business. They would not want the liability. So let's say you see a hurricane coming, and you say, we're a big insurance company, we've created technology, we're going to do some atmospheric heating that will diminish the hurricane, but it's much easier and costs less money if we just divert the hurricane. We create a little pocket of hotter air at a certain altitude, and that shears the top off the hurricane. You could do that. But what about creating it at a different altitude, and it doesn't allow the hurricane to want to move in that direction because the atmospheric pressure from the heat increase is too high, and the hurricane takes a right, as the saying goes, takes a dog leg. And the hurricane now takes a dog leg and heads up to, I don't know, Bermuda. Or they miss Bermuda and go, it's going to hit Charleston, South Carolina. Well, if somebody in Charleston, South Carolina actually found out that the insurance company paid to have the hurricane not hit Florida because they would have lost too many billions and there's fewer people in South Carolina, even if they get totaled, they've got insurance, will pay out. But when they find out that the insurance company had a weather modification net that actually redirected the hurricane to them inadvertently, but to them in South Carolina, they could create a class action lawsuit and sue the insurance company into oblivion. So I don't think the insurance companies are incentivized to create or actually deploy the technology, but they're certainly incentivized to talk to the elected officials that they help get elected with their campaign contributions and say, hey, government official, why don't you spend some money on weather modification, but don't say we said so. And then, play around with it a bit. In the meantime, the insurance companies will still sell what they can make good money on, like vehicle insurance. But if you know from the last couple of hurricanes that hit Florida, the number of water damaged vehicles was in the thousands. And the insurance companies were going, we'd like to stop selling not only home and business protection insurance in Florida, we'd also like to stop selling automobile insurance. And the state of Florida said, Florida's a no-fault state. If you want to not sell insurance, you don't get to sell any insurance because that's the only game you have left selling. So if you find insurance for vehicles not profitable in Florida because you're having to pay total damage on too many cars that got totaled by water, you got another thing coming. And if you know the history of Florida and you think back to the late 1920s, when thousands of people died because the dike system around Lake Okeechobee didn't exist and the Florida flood control districts didn't exist, and then the government created them, and the insurance companies breathed a sigh of relief because they no longer have to pay for injuries, long-term care, and life insurance payouts for people drowning in hurricanes. Well, now that hurricanes are getting to be more intense, they're thinking like, well, if you don't want to have medical and life insurance in Florida, especially Medicare assistance, think again, you got another thing coming, because there's other companies willing to step up to the plate and pay. So I think the insurance companies are incentivized to knock the weather down a bit, but they're counter incentivized to not do it themselves, but to maybe use their campaign contributions to go have the government do it for them. Of course, just my opinion. So who has the funds to do it and has the just cause to do it? That's governments. So government's going to be hit by this stuff. But what is the core aspect of government at the federal, national level that really stands to gain if weather events don't happen? That's military readiness and the effort required for the military to recover should a weather disaster hit. And the U.S. Department of Defense has actually done war games, computer simulation exercises to say, what if we have a flood disaster? What if we have a Cat 5 take out a few military bases, an F5 take out a few military bases? And they found that it is definitely in the incentive of the U.S. Department of Defense to pay attention to what is known as climate change, global warming, those kind of things, because they're watching the potential for natural disasters happen. And that's naturally occurring disasters. But if they can be deliberately made to occur or be worse, the military is going to want to know how this is done, how to deal with it, how to mitigate it, and maybe how to make the bad guys, our adversaries, have a bad day. So, yeah, there are parts of the government that are incentivized and have the billions in funding to mitigate it, but also to know the technology to make it happen. Scary but true. But nobody's ever done this stuff. This is all science fiction, right? Wrong. You may have heard of the concept of seeding clouds. Historically, this has been done using silver iodide crystals. They have what looks like flares on tubes hanging off the back ends of, oh, you don't need a jet. A prop job's okay. It moves slower through the air, so it can better disperse these silver iodide or silver halide crystals. The silver halide or silver iodide does not dissolve as easily in water. So you can spread these microscopic crystals out into clouds, which are water, fog, hanging high in altitude, and you can make, due to static electricity and chemistry charges, make the water collect on the outside of the crystals, making the crystals heavy and therefore pulling down the water out of the clouds. That's what cloud seeding is. The crystals act as seeds upon which the water will collect and make the water fall. But in 1977, they started performing this in Nevada and Colorado in the US. Initially, this was done by a division of the University of Nevada. That's been branched out now that they saw there's money that can be made from this. And there's an organization called the Desert Research Institute, or DRI. And you can see here is a map from the DRI that says, here's the areas where we've been recently cloud seeding. So if you have an issue with them, you can take it up with them. Well, cloud seeding is so popular that NOAA, the U.S. Department of Commerce, said, why don't we cloud seed hurricanes to make them drop their water way out in the Atlantic Ocean? So you will occasionally see to this day little test efforts of NOAA cloud seeding hurricanes to reduce their water downfall during, hitting Puerto Rico or whatever. But the same thing can be done using dry ice as opposed to silver iodide, silver halide. Dry ice does the same sort of thing, but unfortunately, dry ice dissipates or outgasses in the presence of water. So if you can get the dry ice up into the clouds to make the crystals and pull it down fast enough, you can use dry ice blown out as crystalline form to seed clouds. This is a real thing. It's being commercially done. Places that want their agriculture to be wetter and they're in pseudo-desert regions or they haven't seen a lot of rainfall, they can actually pay money to the Desert Research Institute. No guarantees, but they can seed your clouds. So this is the one that most people don't believe actually exists, but it does. Shearing tops off of hurricanes. Cloud seeding might reduce the amount of water in a hurricane, the amount of waterfall, but it's not going to do anything to the winds unless the waterfall cools the core of the hurricane and therefore it slows it down, but it won't dissipate it. To push around or shear off the top of a hurricane, you need a small change in atmospheric pressure, increase it over a very large area. And the way you can do this is by something known as atmospheric heating. If the area can be heated intensely enough, you can actually heat the air at an altitude that is right at the top of the hurricane, and the increased atmospheric pressure will cause a wind flow counter to the rotation of the hurricane and actually shear the top of the hurricane off. This is where, I don't know what happened to the hurricane. It just went gone. And it went from like a category 3 to a tropical storm overnight. They'll talk about wind shear, and the wind shear topped the hurricane. Yeah, that's a real thing. But did nature cause it to happen? Or did technology cause it to happen? Evidence is needed. You know, for extraordinary things, you need extraordinary evidence. Just wait a few slides. So you don't have to actually put out enough energy to force the big enough change to shear the top off the hurricane. Maybe sometime you just want to be a no landfall hurricane. Just direct it out in the middle of the Atlantic Ocean. It's going to go north enough that if it doesn't hit Bermuda, it's going to go north enough that it's going to dissipate due to temperature change alone. So all you really need to do is, before the hurricane gets to the coast of Florida, you need to create a buffer zone of higher pressure, and that takes a lot less energy. You're just somewhat heating the area. Think of it as if you heat water, it's going to increase the pressure, you know, a pressure cooker kind of thing. But how much hotter do you need the atmosphere in order to change the barometric pressure by, I don't know, a few millibars? Well, a few millibars over a large area could be megawatts of energy, but do you have megawatts to throw at it? Well, turns out might have that. So when you increase the heat in an area, you can see it naturally. So if you're at Walmart and you go into Walmart and then it starts raining a little bit before you come out, and the rain stops, and then you come out and the sun's shining, you'll see like water vapor coming off the asphalt at Walmart. Well, what actually happened was the water hit the hot asphalt, and the hot asphalt it wasn't 212 degrees, so the water didn't boil, but the atmospheric pressure was such that the vapor pressure of the water transitioned the water from liquid to vapor. So microscopically, it boiled the water. But you know, there wasn't enough energy to vaporize your car or to kill people in the parking lot. It was just enough to transition the pressure by a few millibars. That's not much, but it's over a very large area. So the idea would be, how much do you have to change it over how large an area in order to tell a hurricane, you like low pressure. This pressure is a little too high for you. Go elsewhere and steer the hurricane. Well, if you look historically at hurricanes in Florida over the last, I'd say, 10 years, a lot of them do that dog leg maneuver as they get close to Florida. Well, look back and you'll see that the predictive barometric pressure, that little squiggly line maps, said Florida was looking like it was going to get hit by the hurricane. And then that was the 5-day forecast. And then all of a sudden the 2-day forecast says, there's a high pressure zone that's forming over Florida. From where? Well, nature. But nature was the one that said Florida's ripe for the hurricane. And then all of a sudden, nature changed its mind due to what? One could conjecture. So now we go from fantasy to reality. What you've seen so far in these slides is the analysis of what adverse weather events cost businesses, human life, healthcare, recovery, just the whole ball of wax, so to speak. And then who would want to spend the money to make the technology exist to mitigate, maybe not cancel, but mitigate things? What's the profit motive? What's the liability? All those things were discussed. Now we'll get into the real world stuff. So there's a place in Canada, Alaska. Canada's off to the right. There's a place in Alaska called Gakona, Alaska. And there is a large array of little radio antennas, hundreds of them. And they don't use them for, like, seeing if ET's phoning home. And if you see the picture at the top, you see the white building in the background. That's the operations and power generation facility. So in 1993, the U.S. Defense Advanced Research Projects Agency, DARPA, the black box research folks for the U.S. government, the technology that nobody needs to know about until we want them to know about it. They worked with the Air Force and the Navy to create HAARP, which was originally named the High Altitude Aurora Research Project. Now, Aurora, high altitude, mentioning. The Air Force wanted to study auroral heating. Why would they want to do that? Because they're part of the U.S. Department of Defense, and they wanted to see if somebody else did it first, what would be our effects? And if we wanted to do it to somebody else, what would be our effect on them? And then from a study of nature, how does the ionosphere behave if we inject microwaves into the atmosphere? The Navy said, we'd like to use your array. We're talking with our submarines. You remember me a couple of months ago talking about very low frequency radio, the extreme low frequency ELF? So when we were talking to submarines and it was causing whales' ears to bleed, this was the transmitter. So once we figured out maybe it's not for the things we originally intended, kind of. The ownership of HAARP, not the operational responsibility, but the ownership of HAARP transitioned to the University of Alaska. That's kind of like shove it over into the private sector, so to speak. But apparently it operates year-round, and roads are maintained in the winter by, the Department of Defense. Interesting. What they're saying it's meant to do is to study the atmospheric heating effects at the altitudes of 50 to 400 miles above the Earth's surface. On site, not from the local power grid, but on site, they can generate 12 megawatts of electrical power. The radio array can pump out 3.6 megawatts into the ionosphere over a frequency range of 2.8 to 10 megahertz. Wait a minute, what happened to the whole high frequency and very low and extremely low frequency stuff. The 2.8 to 10 is kind of in the middle. Turns out HAARP at that frequency sends out enough power into the ionosphere to create air glow. Basically, HAARP can create its own aurora. That's how much power it's sending into the upper atmosphere. Now, what's the negative effects of this? Well, they're saying none because, the Earth naturally has an aurora, and the aurora is from solar radiation heating the upper atmosphere. So we're not doing anything that nature isn't doing, so to speak. So in 2014, when kind of the cat was out of the bag and everybody knew what HAARP was all about, atmospheric heating, the U.S. Air Force announced, okay, we're going to shut down HAARP. But they didn't. Even though they said they were in 2014, turns out they didn't. In 2015, they did a little duck maneuver there. They said, we're not going to shut it down. We're not going to shut it down. We'll just transfer ownership of HAARP to the University of Alaska Fairbanks. Well, where would a university get the money to run this multi-million-dollar operation? Oh, that's right. The University of Alaska gets money from the U.S. National Science Foundation and private contractors to operate HAARP. The balance. Federal money to operate and keep HAARP operational 24/7. And then private contractors. Why would a private contractor want to do atmospheric heating? Those Freedom of Information Act requests, why doesn't the media ask for them? Be interesting to see. Now, given that HAARP is only using 3.3 megawatts out of its total, 12 megawatts power generation capacity, they can afford to be magnanimous. And all those little people living in Alaska could use some free electricity. So HAARP, in its good graces, annually donates back to the Copper Valley Power Grid, the local municipality, 10% of its power generation. So your tax dollars are paying for the diesel to run the generators, and it's giving that free to the Copper Valley Power Grid, which happens to be, oh yes, Touchstone Energy has money invested in Copper Valley. They're the commercial power producer. But what it does say is, now that there's a grid connection between HAARP and the local power grid, that means that not only can HAARP give to the local power grid, HAARP can take from the local power grid. So remember me telling you that HAARP can produce 3.3 megawatts of RF radiated power. Well, what if their 12 megawatts of power generation was just not enough and they wanted more? Well, Copper Valley actually has 5 generating plants, just 2 of which are sufficient to meet their summertime demand when you have all the air conditioners running. So Copper Valley, the private power generation facility, can produce 40 megawatts. Let's see, if we just divide that up and say that's 5, that would say 8 megawatts too. So the summertime demand is for 16 megawatts. Why do they need 40 megawatts? Well, just because, in case they need more, room for growth, or it could be that if HAARP needs more than the 12 that it can generate, it can reverse tap into the Copper Valley grid and say, hey, give us a little more juice because we have some big time programs we want to do. So the give back from HAARP to Copper Valley is noise. But, consuming another 2 megawatts off the Copper Valley grid would be a noise drop to the total capacity of Copper Valley. So, where's that Freedom of Information Act? We'd like to know, since our tax dollars are paying for the diesel, which months over the last 10 years consume the most diesel, and what was going on in the tropics at the time. Just, I'm sure it's circumstantial evidence. But remember me saying that HAARP runs 24/7, 365? Yeah. You know that Arecibo's gone in Puerto Rico. The big dish is gone. One of the things that the big dish, or the big ear as they called it, used to do is they would send out radar to near-Earth objects, asteroids out in deep space, because radar is better than optical at taking pictures of the surface texture of, rocks in space, so to speak, comets and asteroids and stuff like that. So with Arecibo gone, how are we doing our radar imaging of near-Earth objects? Turns out we're using HAARP for that. The HAARP array, no matter what time of the year is needed, can be commissioned to beam radar into deep space at high power, high enough to get, out to the asteroid belt on a very narrow beam. So they're not, covering the entire sky. They're synthetically creating the transmitter aperture to be small enough to expand out just to cover the asteroid they're shooting at. And they can track the beam as the asteroid moves across the sky, so they can tell how big is the asteroid, what its surface texture is it rotating, how fast is it rotating, what's its trajectory across the sky, so we can use the computers to plot out, is that a threat to Earth or not? Well, they're using HAARP as the transmitter. Well, what are they using as the receiver? Because, the signal goes out and then it might take a day or so for the reflected radio to make it back to Earth. Well, they're using the Owens Valley Radio Observatory long wavelength array near Bishop, California. Turns out that's another National Science Foundation funded area. They also have the ability to receive the radar at the University of New Mexico at the long wavelength array near Suraco, New Mexico, which is near where the VLA is, also funded by the National Science Foundation. So, remember me telling you a month or so ago that the NASA Deep Space Radio Network is kind of overbooked at the moment with all the deep space probes and all the monitoring it has to do. So if all of a sudden there's an asteroid headed our way or a comet headed our way, and we need to do some analysis of it, HAARP to the rescue. So did HAARP come out of nothing, which went from not having it to like, hey, we're going to build HAARP? Well, no, there was actually in 1975 a predecessor that was created in Europe, 1975. So not the European Union, just some affiliated countries in Europe. They created a couple of giant parabolic dish antennas north of the Arctic Circle, so they could do their own testing of atmospheric heating. Now, they actually tapped into local grid, so they don't have as much capacity, but they were capable of sending 2 megawatts at 930 megahertz, or 3 megawatts at 224 megahertz out in deep space and heat the upper atmosphere. And there's also a large array similar looking to HAARP that also is in Northern Europe, that they're capable of. They have 12 100 kilowatts, so 12 times 100 is 1200. So 1.2 megawatts of power at the 3.85 to 8 megahertz range. So atmospheric heating was a real thing starting back in 1975. And not only did the European countries participate, but also Japan and China did. And when Germany found out what this thing could do and how much it was costing and what could go wrong from a liability perspective, Germany said, out of here. And Germany backed out of the consortium. So it's been going on for a while. You just don't hear about it because it's techie and nobody asks. But do our adversaries do this as well? Well, here's a picture of Novograd in Russia, where they have the SURA ionospheric heating facility. Now, this was created back when the Soviet Union existed, and the Soviet Defense Department paid for the creation of this. So if they were studying atmospheric heating as a weather phenomenon, why would the Soviet Defense Department be paying to have this heating array created? Now, they didn't care how much they drew from the local grid, so it's capable of transmitting microwave energy at 4.3 megahertz to the tune of 80 megawatts. So they were doing this big time. And at 9.6 megawatts, that's 9.6 megahertz, they could put 260 megawatts of radio energy into the atmosphere. Given that this is an array, it's synthetic aperture. So how much area that covers is tunable by software. So if you said, I want to produce heating of 3 degrees centigrade at the lower boundary of the ionosphere, and I want to cover an area of 100 square miles. You wouldn't even need 1 megawatt to do that. There's formulas you can run, but I didn't include the math because math, when you put that in the video, people lose interest and stop watching the video. So let's just say, if you want to do the math, you can do the math to see how much radio energy you can put out that will cover how big an area, because these are software tunable fields of view. But nobody's ever made the connection that, weather modification is something doable, right? Right? When you're watching your weather report on TV and you see the weather person, and they're a certified by the American Meteorological Society individual, they've gotten their education. Well, the AMS website has a historical archive, and dating back to the 1950s, they actually had a research paper that they presented at a plenary meeting. The name of it was Atmospheric Heating as a Research Tool. They were claiming that all you needed was 5 milliwatts per square centimeter of radio energy in the form of microwaves beamed into the lower boundary of the ionosphere, and you could change weather patterns locally, short term, until you turned it off and then they would restore. The abstract of the paper included the following paragraph. This paper describes concepts that use either ground or space-based platforms for generating beams of microwave radiation to provide localized thermal heating or ionization of the atmosphere. So, it's getting real close to saying we want to do atmospheric heating to change the weather, but it's a bridge too far to say that. But they're getting there. We'll get there in a few slides. Interesting to note that one of the companies creating the technology for them to do this was Lockheed Martin. The Skunk Works folks, the people that brought you the U-2, the SR-71, and the F-117A. Part of the funding for the American Meteorological Society comes from Lockheed Martin. They're a corporate patron. So your tax dollars paying for the military engaging a contractor like Lockheed Martin, and then Lockheed Martin doing the complete full loop circle back to give money to the AMS so they can research atmospheric heating. And it's not limited to hurricanes. There was another AMS research paper presented to a Congress, not U.S. Congress, but a plenary session of Meteorologists, preventing tornadogenesis. Kind of a funny word. Concept for thunderstorm intervention. This is like folks sitting down at an AMS conference, hearing a presenter talking about using atmospheric heating to intervene in tornadoes. It discussed mitigation of active tornadoes using microwave heating. They actually said, if you had 10 trucks, making them mobile to chase tornadoes, if you had 10 trucks, each of which was capable of producing 2 to 3 10 megawatt microwave generators. So each truck had 30 megawatts of power generation capacity. I'd have to be a big, multi-tractor trailer kind of thing. They had the ability to beam microwave energy into because if you look at how a tornado forms, you get a downdraft, cold to hot, and it circulates and then eventually starts rotation. Well, if you could take the cold, rainy part and put microwave energy into it, take the cold and make it a few degrees warmer, you would not get the vertical circulation that creates the tornado. The opening paragraph of this presentation says, and I quote, by using beams of electromagnetic radiation from satellites or the ground to heat the fine structure of a mesocyclone, that's this circulation, the formation of tornadoes may be disrupted, not reduced, disrupted, basically killing a tornado before it forms. This was a paper presented in 2011. You think they've taken it any further since then? This was the most shocking part. In 1965, the AMS produced a report out. In other words, they were commissioned by the National Science Foundation, the AMS was, to research weather and climate modification. And they produced a report out back to the NSF, to the NSF's Special Commission on Weather Modification. This was in 1965. In the introduction to the report out to the NSF, how by artificially inducing deliberate changes in the environment may man act to control or develop changes in the atmosphere considered to be desirable by society. So in the beginning slides, I spoke to the things that would make it desirable by society to at least mitigate the debilitating effects of weather events. And in 1965, they were already studying how they would go about doing this and the ramifications of it and reporting that back to the U.S. government's National Science Foundation's Special Commission on Weather Modification. Well, who is this National Science Foundation and where do they come from? Well, in 1950, under the Truman administration, the National Science Foundation came into being. It came into being as a resulting effort from the Roosevelt administration before Truman took over, because they learned that educational institutions and private corporations contributed heavily towards the U.S. national defense during World War II. So under Act of Congress in 1950 in the Truman administration, they created the National Science Foundation to basically be the U.S. military's arm to work with private corporations, defense industrial community, and educational institutions, University of Alaska, to create technology that would say, nature does what we want it to do, not what it wants it to do. And we actually did the work to figure it out. And HAARP was one of those things. And HAARP wasn't the first. And Russia's doing it too. and China's involved in the one that we're doing over in Europe with them. So, yeah, but prior to the existence of the NSF, if you wanted to do this as a collective act, it would take a big push-up to get Congress to appropriate the money to do it. But the NSF has an annual budget in the tune of a few $billions, and the NSF decides where they're going to spend it. So, yeah, there's that. So, in conclusion, since the 1960s, international governments have poured hundreds of millions of dollars into researching and developing the means of altering active weather in chosen regions for the protection of public safety, national defense, and the costs, life-saving, cost-saving, and natural defense. And the most obvious one is cloud seeding, as it transitioned from a university organization to a commercial entity. And they do that, and they still do that. You can pay to have it done to improve your crop yield. But they've also, as a government agency, done research into microwave heating, and more than just the US, and thinking about in actual documents that you can read off the internet. And at the end of this presentation, I give you all the links so you can go read the materials yourself and not say, hey, it's just a crackpot. Well, you can go read the information that I read and go, I'm not scared by any of this. And I'm kind of happy that from a defense perspective, I'm happy to see that we are spending the money to figure out how to do this and, you know, how to defend ourselves from it, how bad it could get, what we might have to do to protect ourselves from it or to stop somebody else from doing it. Now, everything we've done is about adding and heating. Nobody has technology yet to say, and we need to make it colder. So, you know, a certain Batman evil villain comes to mind, Mr. Freeze. So until we have the technology where we can have a Mr. Freeze, there's a few parts of weather modification that are left out. So I said, you know, somebody should file a FOIA request, somebody in media should file a FOIA request to say, I just want to see the diesel fuel consumption rates for HAARP over the last 10 years. I don't care what HAARP's doing. I don't care where they say they're beaming or how much they're beaming or what frequency. I just want to see diesel fuel consumption. And if you see diesel fuel consumption spike, just as a low pressure changes to a high pressure and a hurricane either gets its top sheared off or goes elsewhere, and then you see a few days later the diesel consumption go back to normal, it's kind of, you know, smoking gun evidence. Yeah. But here's a side note. I've talked about advanced forms of deep space propulsion, and one of them is gigawatt lasers on Earth, multiple of them, beaming focused energy against solar sails in space to push over a period of time. Solar sail-based deep space, you know, cosmic level space vehicles, closer and closer to relativistic. You know, you're not going to get to 100% the speed of light, but even if you got to 50% speed of light, then, you know, 4 years to Alpha Centauri would be 2 years. So you get there. But now that we know about atmospheric heating, does sending gigawatts worth of infrared laser power into Earth's upper atmosphere to make the laser leave the atmosphere and hit the solar sail, does that still sound like a good thing to do? I would say no, but that's just me. And I have 3 slides worth of links. So about cloud seeding, why cloud seeding works, shearing the tops off of hurricanes, and yeah, and this is something that NASA is talking about. HAARP, if you want to know more about HAARP, the local power grid and the handoff between the two of them, and then using HAARP as a substitute now that Arecibo's gone as the radar transmitter. and then the receiving portion, the Owens Valley Array. And then in Europe, the European earlier version of HAARP, and then the Russia version of HAARP. So all that kinds of stuff. And then the AMS paperwork, atmospheric heating as a research tool, and then preventing tornadogenesis. And then the real smoking gun from the actual National Science Foundation, Weather and Climate Modification, a report to the Special Commission on Weather Modification, National Science Foundation. I didn't have to go through any back doors or hack anything. These are publicly available research papers. Feel free to read them or not. So that was fun. That was some deep rabbit holes.
Yeah.
Comments, questions? So before you heard this presentation, how many of you had even heard of the concept of weather modification?
Vaguely, but not to this extent, of course.
Yeah. You probably have heard of cloud seeding or silver
Yes.
iodide or those kind of things, because that's
Yes.
in the public commercial use
Right, right.
agriculture for decades.
Yes.
But microwave heating of the atmosphere in order to create higher pressure bubbles to push hurricanes away, or doing it more intensely and focusedly on a very local basis to dissipate a tornado such that it never forms. That one to me was just like, yeah, if I looked any further into that one, I know I was going to find the name of the commercial contractor that's producing the trucks. So how many people remember the black and white sci-fi movie Earth versus the Flying Saucers?
Me.
If you remember in that movie, the ultrasonic projectors were things on the back of big, heavy trucks, including the power generation. So they would have power generation, and they were projecting ultrasonic sound waves to disrupt the UFOs. So if you were a scientist working for the American Meteorological Society, and you had seen Earth versus the Flying Saucers, and you saw, yeah, we could put a generator on a truck. We can generate microwaves. We can have a parabolic dish antenna on the truck. We can steer it wherever we want it. Let's do some prototyping. So if anybody out there on the internet ever sees a picture of a parabolic dish antenna on the back of a large flatbed truck, along with what looks like a diesel-powered generator, and preferably sees a few of them all hauling ass down the road towards where a tornado was rumored to be coming into existence, I'd like to see the pictures of that, and then have somebody explain to me what it's not. Yeah, that would be like, that's more than smoking gun. You can go find the name of the commercial company that produced the trucks. So just be on the lookout. It's kind of like when Tesla releases the Cybertruck, there's all the hubbub in social media. I spotted a Cybertruck. It's a release candidate. It's not a production one. Oh, yeah, but I spotted a Cybertruck, and there's no release candidate. And I spotted a Cybertruck with a different color or pattern wrap on it. Okay, take all that energy in social media and say, find me some microwave generating weather modification trucks in Tornado Alley. I want to see them. If you just happen to see
something. What is it, Burt Lancaster make a movie called The Rainmaker?
Mm-hmm.
That they can make rain if you beat a bass drum.
Yes, yes. Well, that's the ultrasonic trucks. We're talking about, we've improved that. Now we're using microwave trucks.
Yeah.
With the microwaves, the neighbors can't hear you. So if you're transmitting in a particular bandwidth, megawatts worth of radio energy. Why wouldn't ham radio operators hear that? Hey, I was tuning into my buddies down in Australia, and all of a sudden it just went away. It just like staticky, but I didn't hear like random static. I heard noise, like a tone. So if you transmit radio frequency energy and you don't modulate it, you just put the power out there and you transmit on a very narrow band. If your receiver is tuned to that band, you will be hearing normal stuff, maybe data, maybe people talking, and then all of a sudden you'll hear a very high power hum. That would be like a HAARP. But if you look at the frequency, they give you a very broad range that they can transmit on. And the higher the frequency, the smaller the amount of area they have to cover, because the higher frequency has higher energy per photon, which contributes more energy to the atmospheric heating for less megawatts. So if they pick just the right frequency and it happens to be in a FCC approved slot that's not used by hams, the tree fell in the woods and nobody was listening. That's really spooky action at a distance. As you can tell, I really enjoyed this.
Yeah.
Not because it just like pulled the cover off of HAARP. Oh, it dug into so many other areas and went back, not just decades, but presidential administrations back to World War II.
Now are we going to get Mr. Freeze so we can refreeze Greenland and Antarctica?
Yes, we can.
We need the opposite of what we have now.
Yes, we can change the global warming back to reduce the temperature.
Yeah.
What's the downside of that?
There can't be.
No. Remember, there was a movie, The Day After Tomorrow. You remember where you had just the right convolution of hurricanes and it caused them to go up to like the northern climates where the air was colder, and it caused a front to come through that was, 50 degrees below zero, and it just went through and froze things.
Yeah.
Destroying cities, killing millions of people, and creating havoc. And that was called The Day After Tomorrow.
That's right. Yeah.
Okay.
Yeah.
Well, if Mr. Freeze came along and created the technology for freezing and we got it wrong and we froze and created a front, and the front came through at 10 degrees below zero and hit an area like, I don't know, Florida, we would absolutely not be prepared. Society would come to a halt. People would likely die due to not knowing how to dress to go outside in that cold because they've lived their lives in Florida.
They can't do it at 50 degrees.
Yeah, it's kind of like over in certain parts of Europe where homes date back to the 1800s, and what's air conditioning? They've always had a good breeze, and then they had these 110-degree heat waves come through there for days to a week at a time, and thousands of people died because they couldn't escape the heat, and the heat was such that the humidity and the temperature produced an inability for your body to dissipate internal heat, and therefore you died. That's a thing. So the same can go the other direction. If you create a low enough temperature with a low enough humidity, you will not be able to keep your internal organs at 99 degrees internally. If your core body temperature drops 2 degrees below 99, you're going to be in a hospital. If it drops 5 degrees below 99, you're going to be in intensive care. The human body operates internally on a very narrow threshold. You know the old thing of if you've got a fever and your fever gets above 101, go to a hospital. Because if your fever gets to 105 or higher, you've only got hours left to live. Same thing's true on the cold side.
I'm looking at it and I'm thinking that the hardest part is the in between. When we do a transition to doing something new, there always are going to be problems. There always, you don't know how to fix certain things because you don't know the unknowns. And
well, weather modification is certainly one of those areas where apparently atmospheric heating is considered nature. Therefore, mankind can do it as long as we don't do it too aggressively. But cooling, on the other hand, that's a whole different ball of wax. Now,
I mean, places that are going to still want to be cold because they have skiing and all the activities.
Oh, by the way, remember me telling you the cloud seeding is something you do for ice and snow, not just rain? Yeah, all those areas in Colorado and Nevada where there's ski resorts.
Skiing, sure.
Yes, they pay every few years to have clouds seeded so they will get snowfall on their resort so they can make the Benjamins off the tourists. So there's a commercial incentive for weather modification, both in a negative and in a positive.
Is there a sort of a NORAD equivalent for watching to see if other countries are trying to affect our weather?
Oh boy.
That might be.
No. Think of it for a moment. It's a good question.
It is.
We've had the answer for a long time. The U.S. military has its own meteorological professionals. So when you look at NOAA is the commercial arm of the U.S. government's meteorological services.
Mm-hmm.
Why would we need that? For defensive purposes. If you're going to go to Normandy, the beaches of Normandy, don't you want to know what the weather's going to be like? Yeah. We've had people watching out for the weather as an aspect of offensive and defensive military capabilities since, probably early World War II, and we've not stopped.
Mm-hmm. So they can spot unusual weather patterns, unusual heating, but is there a way to see who is generating that?
Oh, yeah. Think about it for a moment. If HAARP projects microwave energy up into the ionosphere, what's above the ionosphere that could detect that? Infrared satellites.
Yeah.
And let's see, does the U.S. government have any geostationary infrared satellites covering the globe? The answer is yes.
Okay.
So, yes, we can detect when microwave heating is used to heat an area of the atmosphere at any layer that differentiates between natural effect. Yeah, we can see it.
Interesting.
Yeah, it just, the dots connect together almost as if there's a plan. We have to defend the country from anything, not just guys with, sticky sticks and bang bang guns and bombs. We have to defend us from other things too. And when we're going to do military maneuvers, we have to know, should we dress for the occasion? Because if you're going to go do a military maneuver in an area where it's going to be hot, you need to think about how many pallets of water do we need to ship there before the military maneuver so our troops don't die of thirst? How many portable air conditioners are we going to need for the field hospitals? How do you know these things? You got to know what the weather's going to be like. How do you know that? Well, there's got to be a branch of the military that watches the weather.
Makes sense.
It's that big government that some people who don't comprehend it want it to go away. I'm very glad that there are things in the big government that we don't need to know about, but if you want to know about them, you can go look at them and find out all about them. And that's just the things that aren't dark, aren't black projects. So all of that originally was dark stuff. And as it got proven and reliable and used on a regular basis and monitored on a regular basis, they don't announce it. It's just no longer hidden. So scratch below the surface, you can find these things. They're not hiding it.
It's going to be important too when we go to other planets to be able to control the weather there.
We are already examining the weather on Mars because every 5 years, Mars has a cyclic dust storm that covers the entire planet for months.
Boy. I didn't know that.
Yes. We actually sent an early Mariner space probe to fly by Mars, and we didn't know about the dust storms. Coincidentally, when we sent the probe by, the dust storm was completely covering Mars. We got no pictures whatsoever.
Interesting.
How long did that last for? Is that for months or?
It can last for several months, yeah. Completely covering the whole planet.
Wow.
Yeah.
That's a big
We know the short-lived seasonal dust storms because if your lander or rover on Mars is solar powered and the dust storm hits it and covers your solar panels and you can't make enough power to keep your equipment heated through the Martian winter, your probe is toast. Same thing happens on the moon. But that's not dust storms, that's just tilt angles of the moon. And are you going to stay dark for too long? So yeah, we do obviously watch the weather elsewhere.
That's got to be a big problem.
When somebody says, how much does U.S. Defense Department cost us annually? And somebody says, $800 billion. Not all of the $800 billion is on making things go boom or stabby or tanks or airplanes. Some of it is probably hundreds of millions of dollars just to make sure we're not going to have a bad day when we don't want to have a bad day. Some of it is just monitoring. No, we'll attack on Thursday instead of Wednesday. Some of it is we need to attack now. How can we improve the current weather? Microwave heating. And we don't even have to produce enough microwaves to pop popcorn. It's just, like they were saying, a few milliwatts, that's thousandths of a watt, over square centimeters. Now, a square centimeter is about that much. I guess a little bit larger than a postage stamp. But you're going to do that over, 100 miles by 50 miles in an ellipse. So it's a few megawatts. We've got a few megawatts to spare. This is not meant to scare you. It is meant to say, when you learn about some of the downsides of this stuff, there is a government, it does exist, it has been researching it, it has been helping out, and it never bothered to tell you, and you never knew to ask. So sometimes it's good. Okay, I'm about to turn off recording. Anybody want to say anything that is recorded?
Should we be trying to use technology to refreeze some of these icebergs and things that are melting?
Yes, but like I said, we don't, as far as I've researched and know, we do not have the weather modification technology to cool things down. We only have the weather modification technology to heat things up by applying photons in radio frequencies. However, if you study the efforts to get things to 0 Kelvin, like absolute zero, the latest trend in getting atoms to stop moving around, which is heat, getting it closer and closer to 0 Kelvin, the way they've been doing that is with lasers.
Ooh.
Think about if you had a bunch of ping pong balls that were all bouncing around, and you could shine a light on the ping pong balls, and the light reflecting off the ping pong balls transferred momentum to the ping pong balls, then the ping pong balls that were bouncing higher would be the first ones to receive that momentum, which would stabilize them, push them down. And if you kept pulsing the photon stream, you would gradually be pushing the atoms down so that their molecular motion was less and less and less, thereby cooling the atoms, reducing their infrared heat to get closer to 0 Kelvin. So somebody someday will connect the dots and go, we're thinking of radio energy as a means of heating up the atmosphere. What if we were using, femtosecond lasers in the optical band to push on the hot water molecules in the atmosphere to cause them to be contained so they weren't so turbulent. And if you reduce the turbulence of heated water molecules, that would reduce the temperature and thereby the pressure would drop. So if you reduce the temperature and you decrease the pressure, you have more of an Arctic flow than you would otherwise. So maybe somebody will connect those dots someday. That's just me thinking out loud. Going, I see what they're doing there. I know what they want to do there. Get the finger puzzle together. Get it where once you stick your fingers into it, you can't pull your fingers out.
It will be done, I'm sure.
I'm hopeful that somebody in the government somewhere is thinking about this and maybe doing some engineering model research in a lab or computer simulations, because there are human brains in Russia and China, North Korea and Iran, and they can think too. So don't you want to be the first kid on the block to think?
Well,
I certainly would want our government to think. And I'm willing to thank them with my tax dollars.
Thinking
that's just my opinion. I could be wrong.
Yeah, if we really started to go into this, you could do things like rerouting the jet stream and all kinds of stuff.
There's money to be made in that too.
Yeah.
Because if you have a horrible winter coming down into a less than northern state and you wanted to stop that Arctic breeze or change it from, 12 degrees below zero to 5 degrees above zero, if you could do that, how much would that be worth?
Yeah.
Keep the kids in school, how much does that cost? I'm sure that the parents of the COVID-19 era will go, you mean instead of having snow days, the kids would stay in school? Yeah. Just thinking out loud.
Then people wouldn't have to come to Florida. It would be nice.
Okay.
Use the technology to convert the excess carbon in our atmosphere to diamond rain, like Neptune.
I think that would be an exotic level of energy.
Yeah.
But think about it this way. If you reduce the temperature and the atmospheric pressure, the CO2 will do what? It will get colder. You know what dry ice does?
Oh,
I was today working with multiple containers of dry ice with water in the bottom of them. And if you said, what if the water was the ocean and the dry ice was not actually frozen CO2, but atmospheric pressure CO2, and I reduce the temperature and I reduce the atmospheric pressure, the CO2 will descend. That's how you put fires out. You blow the CO2 on it and it lays low to the surface, pushes the oxygen up and suffocates the fire. Well, if you did that on a very, very small scale, as far as delta, but over a large enough area, if you could cool and reduce the pressure, you could very, very much make a portion of the CO2 in the atmosphere descend. And if you did that and there's still plankton on the surface of the ocean, they would be very happily greening up from all the extra CO2 they would get.
yeah. That would be super.
photosynthesis. So, yes, there is a real reason why you would want to drop temperature just a few degrees above the ocean to make the CO2 descend, or you could take it even more and say, I want to drop the clouds above Greenland to increase the amount of snowfall rather than rainfall, because rainfall melts glaciers from the bottom up and causes them to slide as a lubricating force. But if I can have snow fall on the top of the glaciers, I'm building the glacier back up. So, yeah, if you can control the weather, then you can control the weather. But if you can only do it on a small scale, it's still beneficial.
Well, they used to talk about weather domes. They don't talk about that anymore, do they?
No, because it's too expensive to build a dome.
Yeah.
There is actually a dome out in the southwestern United States where they tried to have people live in the dome for a period of time as if they were on Mars, and it didn't provide the resources they needed to sustain the people that they had in there, and the people were psychologically ill-prepared for the social tensions of, what we experienced with COVID.
Yeah, they ran out of
Locking people into an area.
That's right. They ran out of paper towels. I remember. Yeah.
Well, that was just one of the things.
Yeah.
But
Yeah, I hate that when you're on Mars and you run out of toilet paper. That really
That's right. What do you do? Yeah.
they've already thought of that, and you don't use toilet paper.
Oh,
Ew, what are they doing? Have you ever heard of a bidet?
Yeah.
There you go.
on Mars. Yeah. All right.
No. Elsewhere.
Yeah.
How about the ISS? Oh, we have to keep the ISS stocked with toilet paper. Does that make sense? No, it makes more sense to blow water over the dirty bits and then use a hot air fan to dry it off. No paper needed. But how do you wash your hands? I don't know. How did we do it during the pandemic when you were out in the middle of nowhere? You squirt the gel on your hands that has alcohol in it. You rub your hands together, and voila, your hands are sort of clean. Nobody ever wanted to answer the question I would ask. So the alcohol is the main ingredient for rupturing the cell wall of the bacteria and killing the germs. Inside the bacteria, there are toxins. So when you rupture by the millions all those cell walls and then the alcohol evaporates away, your hands are covered with toxins.
Right, exactly.
Yeah.
For the man behind the curtain. Ignore the man behind the curtain. Stop asking questions for which we don't want to know the answer.
I've been rubbing this stuff on my hands all night.
Yeah. Well, you've been increasing the level of toxicity of your hands. Now, if all you did was rinse your hands off in warm water is a great solvent. It will keep the biology intact and wash it out of the crevices of your skin down the drain. You don't even have to use detergent. So, yeah. I mean, we do dumber things. You're going to go in the restroom, you're going to wash your hands off, and then you're going to stick them in a giant fan that blows the bacteria-laden water all over the place, in the air for you to breathe, on the walls, on the floors.
Exactly.
And the way you know this for a fact is the air blade, or the air blower bathrooms. Have you ever noticed directly below the blower, there's a little rubber crisscross mat to catch all the water that's coming off of your skin so it evaporates? Ignore the man behind the curtain. Don't ask the questions for which you don't want to know the answers. Now, I will say the continuous loop of cloth paper that you used to roll back when I was a kid and dry your hands off, and if you had enough people going through the bathroom continuously, the rolling towel always became wet.
Ghastly.
That was a source of a problem. But paper towels that had, nothing on them except fiber, and you dried your hands off with them after using soap. You dried your hands off, and they went into a large round bin that was emptied on a regular basis. That was actually not a bad solution. And if you want to know, well, what would be better than that? Well, if you can spare no expense, visit the prep area or the recovery area of an operating room where you have to actually be clean, bacteriologically speaking, clean. So the physicians and the nurses wash all the way up to the elbows. They actually have towels that are not one-time use, but they dry off with them. They throw them in a biological hazard bin, and then they get refurbished, washed properly, and then returned. That's how they dry off. One time, from their perspective, one-time use cloth. And then they put a disinfecting powder on the hands, and then they put on gloves that go all the way up to here. Mm-hmm. So a gown then goes over them, and the gown overlaps all the way down to their wrist. And now they're sterile. And when they come out of the OR, they have somebody pull the gown off from the front of them and put it in biological hazard. And then they have somebody peel the gloves inside out and pull them off their hands. Same thing. And then they go through the same washing procedure to wash all the way up to the elbows. And they get another towel to dry off on. So that's clean. But that costs way too much money for the average, restroom to do.
Yeah, my auto mechanic does
that. You wouldn't want to do that on an everyday. Even the people that go to surgery, they only do it when they're going to surgery and coming out of surgery. Not because of cost, but you would be destroying your hands if you did that every single time you washed.
They do. That's why there are moisturizing lotions that they put on their hands after they've unscrubbed, after they've rescrubbed at the end of surgery.
Right.
Because it is so oil stripping, skin drying. I talk to surgeons, and you always look at a surgeon, they have the best looking skin on their hands. It's because when you wash to that level, there's no bacteria that can get into your skin, causing it to have imperfections, spots, dried areas, patchy areas. And whenever they get out of surgery, they're moisturizing their hands, and and they're always bacteria clean after surgery. So clean and moisturize, you can't do anything better for the skin.
Yeah.
But again, scratch below the surface. You may like the answers, or you may not like the answers. And if you don't like the answers, I'm sorry you asked the question, but sometimes that's the question and there's the answer. Okay, I'm going to stop recording now.